Let's look at the second type of UML diagram, the class diagram. The class diagram depicts classes and their interrelationships. It's used for describing the structure and behavior in the use cases. It provides a conceptual model of the system in terms of entities and their relationships, and it's used for requirement capture and for end-user interaction. Class diagrams are static diagrams. That is, it represents a static view of an application. It's not only used for visualizing, describing, and documenting different aspects of a system, but also for constructing executable code of the software application. Class diagrams describe the attributes and operations of a class, and also the constraints imposed on the system. They are widely used in the modeling of object-oriented systems because they are the only UML diagrams which can be mapped directly with object-oriented languages. A class diagram shows a collection of classes, interfaces, associations, collaborations, and constraints. We said it's a static diagram. It's also called a structural diagram. Each class diagram is represented by a rectangle that's subdivided into three compartments, as we'll see on the next slide. You have the name of the class, you have the attributes of the class, which is the data, and you have the operations, which are the methods, the things that the class can do. In the Visible Analyst and other software tools, you also can place modifiers. Modifiers indicate what other classes have visibility over the attributes and operations, and we'll get into that later. Plus means it's visible to everyone. The pound sign is used to note protected visibility. Only some people, friends, some classes, friends and derived classes can see it. Minus means it's private. No one can see inside the attributes and the operations. But unless you use one of these modifiers, attributes are hidden generally by default and operations are visible. The purpose of a class diagram is to model the static view of an application. Other UML diagrams like activity diagrams and sequence diagrams can only give the sequence flow of the application. However, the class diagram is a bit different. Specifically, the purpose of the class diagram can be summarized as 1. Analysis and design of the static view of an application. 2. To describe the responsibilities of a system. 3. As a base for component and deployment diagrams. And 4. To serve in forward and reverse engineering activities. So, here we see a class diagram, 3 compartments, if you will. The name of the class, the attributes, which holds data values, and the operations, or the things that the class can do. The class diagram is basically a graphical representation of the static view of the system and represents different aspects of the application. A collection of all of the class diagrams represent the entire system. Now, there are 2 kinds of relationships between classes. You have the generalization, which is the inheritance hierarchy, parent-child relationships, and you have associations, which we haven't looked at yet for classes. For example, a student object enrolls in a course object. And associations are of 2 different kinds. You have aggregate or aggregation associations, and you have composition associations. Each of these are slightly different in their nature and the characteristics that they represent. So here's a generalization. We've seen this. Between classes, you use the arrow again. Note the consistency of using the same symbol in use cases, where the arrowhead points to the supertype, the more general class, and at the ends you have the subtypes, the more special specialized classes. Again, the supertype is the parent, the subtypes are the children. For example, a customer is an abstract class, but there may be concrete specialized types of customers, a regular customer and a loyalty customer. Inheritance is a required feature of object orientation, and it's used for abstracting details in several layers. Note again that the parent is always abstract. There are no objects. The children are concrete. They have instances or objects.